this video, we're going to review this exponents and log review. Okay, first problem. When you look at this, you know that 3 is going to be the star of this movie. Whenever you see 3s, 9s, 27s, you know that you're going to have to move everything to the base of 3. In addition, the next thing I notice is that you have action up here in the numerator and action down here in the denominator. You have a 1 here, which is boring. Underneath this 3 to the x power is a 1. So you know at some point in this problem you're going to have to move the 27 up to the denominator or the 3 to the x down to the numerator. So let's do the latter. So the problem is 3 to the x equals 1 over 27. First thing I'm going to do is convert this to 3 over 1 to the x power. Then I'm going to flip that. So I'm going to change that to 1 over 3 to the negative x power. I mentioned that 3 is going to be the star of this movie, so I'm going to convert 27 right away to 3 to the third. Now I'm going to apply the power rule. I have 1 to the negative x power over 3 to the negative x equals 1 over 3 to the third. Now, ladies and gentlemen, this negative x has nothing to do with the negative or the positive in front of the number. That negative x only refers to flipping the fraction. Anything to the 1 to the anything is always going to be 1. So I'm going to get rid of that. And now I'm simply going to pattern match. So if 3 to the negative x equals 3 to the third, the bases are the same. These are equal fractions. Everything else is equal. So negative x has to be equal to 3. So I make a little separate equation here. Negative x equals 3. I have not solved for x because this is really negative 1 times x equals 3. I'm going to divide both sides by negative 1, and my final answer is going to be x equals negative 1. Next problem. Okay, I see 3s, I see 9s. Immediately I know that 3 is going to be the star of this movie. So I'm going to go ahead and right away, I'm going to keep 3 on the left as 3 to the 3x minus 1 equals, I'm going to convert 9 into 3 squared to the x minus 3. I'm going to apply the power rule in reverse. That's going to be 3 to the 2x minus 6. Now I pattern match. I have 3 to the 3x minus 1 equals 3 to the 2x minus 6. Therefore, I could set these equal to each other and then go ahead and solve for x. Okay, that solving for x in this situation is too basic for the scope of this video, so I'm going to let you folks do that. Okay, next one. Same thing. Who's going to be the star of this movie? None other than 5. So I'm going to do the same thing that I did in this problem. I'm going to convert 25 into 5 squared, and then I'm going to distribute the 2 to this exponent and then solve for x. So let's move on. Okay. Now we're on number 4. Who's going to be the star of this movie? When you see 4s, when you see 8s, you know that 2 is going to be front and center in this problem. So immediately I'm going to write 4 as 2 squared. I'm going to rewrite 8 as 2 to the third. And I'm going to put in the exponents. Sorry, I left that one out. And then to the x plus 2. I'm going to distribute the powers in reverse, and I'm going to end up with 6x minus 2 is equal to 3x plus 6. And then I'm going to solve for x, which you know how to do. Okay, let's move on to number 5. Okay, what's going on here? In number 5, we see 9s, we see 27s. Who's the star of this movie? None other than 3. Okay, so even as I write the problem down, I'm going to change 9 to 3 squared. And we're going to have 2 minus x equals 3 cubed to the x over 3. I'm going to distribute in reverse, and I'm going to get 4 minus 2x equals 3 times x over 3. Don't be too proud to do this carefully like I've done here. Don't try to do that necessarily in your head and mix it up. Excuse me, and get that wrong. So now these 3's are going to cancel, and you're going to solve for x, which we all know how to do. Next one. Okay, what's going on here? We see 3's. We see 81. We know that 81 is 9 times 9. We see a 3. We know that 3 is going to be the star of this show. In addition, we see action as 81 in the numerator. We see action down here in the denominator. So we know at some point in this problem, we're going to have to flip one of these so that all the action is at the same level. So I'm going to choose to take this, and I'm going to flip that, and I'm going to change the sign of that exponent. So I'm going to write what's on the left as is. I'm going to flip the 81. Let me show you how to do that in steps. It's initially like this, 81 over 1. Don't hesitate to use hidden ones like that. Sometimes they clarify issues beautifully. Okay, now I'm going to take this and flip it and make it 1 over 81 and change the sign to positive x. Now, when I distribute that power, I have 1 to the x over 81 to the x. 1 to the x, 1 to anything is 1. So now I have 1 to the x plus 6 over 3 to the x plus 6. All I did was distribute the power here. 1 to the x plus 6 is going to be 1 because 1 to anything is 1. Now I'm going to bring this down, but I'm going to change the 81 to a power of 3, and that is going to be 3 to the 4th power. Now I pattern match. So now I'm going to set this equal to that. X plus 6 equals 4, and then I'm going to solve for x, which you know how to do. Next one. Okay, we're going to evaluate these logs. The way I like to do this is we're trying to solve for x. So I'm going to put an imaginary x after each of these problems. Then I'm going to use the whirly-bird technique where I take the base, I raise it to x, and that's going to equal the argument. Let me show you on the first one. Subsequent ones, I'm just going to write it right away. Okay, here's the argument, 1 over 32. Notice it is positive, making this legal, and we're trying to find x. So the whirly-bird technique, 2 to the x equals the argument. 2 raised to the x equals the argument. Okay. Now, I should have said at the beginning, I see 2's, I see 32's. Who's going to be the star of this? None other than 2. So let's take a look now at this exponential equation. We have action down here in the denominator, 1 in the numerator, boring. We have 2 to the x in the numerator, right? If I make this a fraction, we know that we're going to have to flip one of these. I think it's going to be easier to flip this one and make that negative. So let's do that. Let's flip this and make the power negative. So it's going to be, instead of 2 over 1, it's going to be 1 over 2 equals negative x. Okay, I'm going to rewrite that down here. 1 over 2 to the negative x power is going to equal 1 over 32. But instead of writing 32, I'm going to go ahead and convert that right away to 2 to the 5th power. Okay. How did I get 2 to the 5th? 2 to the 3rd we know is 8. And we know that 8 times 4 is going to give us 32. So we know that this has to be 2 squared. When you multiply, common base, that's going to give you 2 to the 5th. Okay, now we're going to apply this negative x here and here. 1 to anything is going to be 1. 2 to the negative x is going to equal 1 over 2 to the 5th. We're going to pattern match. The base is the same. That means negative x must equal 5. So negative x must equal 5. We divide both sides by -1. Therefore, x equals -5. That is your final answer. Next one. Okay, we're evaluating this right here. Okay, whenever you see log to the base 5 of 5, that's going to end up being 1. Okay, but let's break this down and do this more systematically. Okay, so we have log to the base 5 of 5 times the square root of 5. The property of logs lets us separate these. Log to the base 5 of 5 plus log to the base 5 of 5 to the 1/2 power. Ladies and gentlemen, don't be afraid of these radical signs. Just convert them to the fractional exponent, and that'll make your life much easier. Okay, so we have a couple things going on. First, we have this right here. And if you are not aware of the fact that log to the base 5 of 5 equals 1, you can do a little miniature equation over here. So let's do a little miniature equation and evaluate that. So what we're going to do is we're going to take log to the base 5 of 5 and set that equal to x. We're going to evaluate x, and then we're going to replace it for what we have here. So let's evaluate x. How do you evaluate x? We do whirlybird. So now we have 5 to the x power equals 5. There's a hidden 1 here. That means x must equal 1. So if log to the base 5 of 5 equals 1, we can replace this with 1. But again, if you memorize the fact that when you take the log with a base 5 and the argument is 5, they neutralize each other to get 1. Okay, so now we have, let's get rid of all this. So now we have this replaced with simply 1. Okay, now we have to evaluate this. Okay, the first thing you want to do when you see this is you bring this 1/2 out front. Okay, so that's going to change to 1/2 times log to the base 5 of 5. Well, we already know that that's going to be 1. So you're going to have 1/2 here. Your final is going to be 1 plus 1/2 equals 2 3/2. Next one. Okay, log to the base 10 of 0.01. Okay, the first thing I'm going to do is I'm going to convert that to a fraction. Okay, so let me write that down as log base 10, and I'm going to change that argument to 1 over 10 equals x. I'm going to do whirly. I'm going to get 10 to the x equals 1 over 10. Okay, we have action in the numerator, action in the denominator. I'm going to flip this. So instead of 10 over 1, I'm going to change that to 1 over 10, and I'm going to change the sign of the exponent. Okay, I'm going to apply it there. It's simply going to be 1. I'm going to apply it down below, and I'm going to get 10 to the negative x equals 1 over 10 to the first. I'm going to set negative x equal to 1. Divide both sides by -1. Final is x equals -1. solve. Okay. I see 3s. I see 27s. Who's going to be the star of this show? 3. Nothing to do with the 3 here, but right there we know that that is going to involve 3. Okay, how do we do this? What is log to the base 3 of 27? If we take log to the base 3 of 27 equals x, we're going to get 3 to the x equals 27, which equals 3 to the third power. So if this equals that, then x equals 3. Okay, so this was a little mini problem that we wanted to evaluate the left side of this equation. We now know it's 3. Therefore, we could set 3x plus 6 equal to 3, and you folks know how to solve that. Next one, right here. We see 9s, we see 3 right there. We know that 3 is going to be the star of this show. We're going to look for ways to get the base of 3 involved in this situation. Okay, so first thing I'm going to do here is I'm going to take this left side of the equation. I'm going to try to evaluate that. And then once I get my answer, I'm going to set it equal to x over 3. Okay, so how do we do that? Well, if we say log to the base 3 of 1 over 9 is equal to green x, that's different than this x, okay? Then we know that 3 to the x equals 1 over 9 equals 1 over 3 squared. We change this to 1 over 3 to the negative x squared. We are going to get 1 over 3 to the negative x equals 1 over 3 squared. Negative x equals 2. X negative 2 equals x. So now we could set this to negative 2 over here. That's what this evaluated to. Okay, so let me clean this up a little bit. And we can make that negative 2 over 1. We can cross multiply. Anytime you have two fractions facing each other with an equal sign in between, that is a license to cross multiply. So now we have x times 1 equals x, and x equals negative 6. Okay? Next one. Number 12. Okay. I see 6s. I see 36. Who's going to be the star of this show? It's going to be 6. So immediately I know it's going to involve me making this equal to 6 squared. That's the first thing that jumps out at me right here. Okay. So I'm going to do this one a little differently. I could evaluate this, do a little mini equation, find the answer, and set that equal to 2. That's what we did last time. But I'm going to do this one a little bit differently. We're going to do whirlybird right from the beginning. So we're going to have 6 to the 4x minus 2 equals, and instead of writing 36, which is the argument, I'm going to change that to 6 squared. So immediately you can pattern match 4x minus 2 equals 2, and then you solve for x. Next one. Okay, what's going on here? Okay, we see 3s, 5s, 9s. Okay, so this is going to involve 5 squared, 3 squared. That, in my mind, is going to be playing a role. 3s and 5s are going to be the star of this movie. Okay, let's do whirlybird. So we're going to go up and around. So we're going to say 3 to the 5th, 3 over 5 raised to the x plus 4 power is going to equal 25 over 9. That's the argument. I'm immediately going to change that to 5 squared over 3 squared. Okay. Next thing, I say to myself, okay, I am going to change this to 3 over 5. And I'm going to pattern match now, okay? So the first thing is I'm going to do the power rule in reverse. So I'm going to change this to 5 over 3 squared. And if I'm not sure if I did that right, I go ahead and I reapply the power rule to both numerator and the denominator, and I get 5 squared over 3 squared. Okay. So now, ladies and gentlemen, we have this. Okay, let's take this away. Let's move these together like that. Okay, now what do you notice? We have inversion here. So all I have to do is invert one of these. So what I'm going to do is I'm going to invert this and change the sign of that exponent. So this becomes, instead of 5 over 3, it's 3 over 5 to the negative 2. So now I can pattern match these two, and I know that x plus 4 equals negative 2, excuse me, and then I proceed to solve for x. Next one. Express this in expanded form. Okay, so here we see multiplication going on. We see an exponent. We know that at some point, if we're going to truly expand this in its entirety, we're going to end up bringing this 3 out front. But let's start with the basics. And the base stays the same as we expand. So we have log to the base b of y cubed plus log to the base b of z. We're going to bring this out front. 3 log base b of y plus log b of z, and that is your final answer. Next one. Expand this. Okay, now this is a little tricky. Got to be careful here. This exponent is being applied to the entire 2x. So we can do this two ways. We could change this to log of 3 and apply the 2 to both the 2 and the x squared. That's one way to do it. Or we can bring the 2 out front right from the beginning. So that's what I'm going to do. I'm going to bring this 2 out front. So I'm going to have 2 times log the base 3 of 2x. Okay, now I'm just going to work with this for a while. And I'm going to change that to 2 times log base 3 of 2 plus log base 3 of x. And then finally, I'm going to go ahead and apply this 2 to both. And my final answer is going to be log base 3 of 2, or 2 times that, plus 2 times log 3 of x. And that is our final. Okay, next one. Ladies and gentlemen, when you see this radical, don't be nervous. Just quickly change it to 1/2. Log, there is no base listed, so we know that's 10, to the m over 3 to the over n, raised to the 1/2 power. Okay, because this radical comes all the way down. That means it includes both the numerator and the denominator. Now you simply apply the power rule to both numerator and denominator. So you are now going to have that equals the log of m to the 3/2 over n to the 1/2. We now have a situation where we can expand that due to the properties of logs, minus log n to the 1/2. And then final move is to go ahead and bring these exponents out in front. So your final answer is going to be 3/2 log of m minus 1/2 log of n. So immediately I say to myself, okay, that exponent, at some point in this problem, I'm going to be bringing that out front. All right, so we just separate these. And I'm just going to do it as I go. So we're going to have log base a of 4 plus 2 times log of x plus log, all of these are base a, sorry, log base a of y. And don't forget to include base a because they had it at the beginning, so you can't just assume that that is log, because if you just leave it as log, that would be base 10 and they might take points off for that. Okay, next one. Okay, expresses a single logarithm. So now what they're asking you to do is condense. So whenever you see plus and minus equations like that and you're asked to condense, first check that the base is the same, and indeed it is. It's 3. Whatever is positive is going to go in the numerator, and whatever is negative is going to go in the denominator. So the first thing we're going to do here to condense this is to bring this 4 back to x and make that x to the 4th. Okay, so the first one I'll be a little bit more deliberate, and then subsequent ones as we move down the page, I'm not going to do all the steps. Okay, so the first move is to do that. Here's a plus, here's a plus. That means this goes in the numerator, that goes in the numerator. So we have y times x to the 4th log base 3. That is your final answer. And you'll see now that we get to negatives what I mean about that plus and minus. Okay, see that minus sign? Okay, bases are the same. We got a 5 out here, we're going to bring that up. See that minus sign? That means p goes in the denominator. So it's just this simple. You rewrite log to the base 2. You create a fraction. You put p in the denominator. You put m to the 5th power. Done. Okay. Next one. Bases are the same. There's a negative here. Okay, first thing, since this is a coefficient, I'm going to bring that up. I'm going to put this x in the numerator because there's a plus sign in front here. This is y is going to go into the denominator with the exponent of 1/5. Okay, I'm going to rewrite the log with its base, create my fraction. Y to the 1/5 goes down here, and x goes on top. That's it. Okay, what's going on here? Only pluses. Okay, that means we are not even going to create a fraction. I'm going to rewrite log base 10. I'm going to leave it blank because they don't have it. I'm going to put p to the 7th power up top because that 7 is raised to the p, and I'm going to keep q on top because they're both positive. That's it. Done. Next one. Okay. Now here's a case, ladies and gentlemen, where these parentheses don't need to be here. So don't get confused by this. Just take them away. There's nothing here out front that we need to distribute. So use our rule. There's a plus sign here. That means x goes in the numerator. Okay, let's rewrite log base 2. We're going to create our fraction. We need a fraction because we know we have a minus here. Okay, there's nothing to bring up top. X and y are up top. Z is on the bottom. Done. Next one. Again, parentheses not needed. There's nothing out here distributing. Okay, we do need a fraction because we have a negative. So I'm going to rewrite my base. Log base 3. I'm going to draw my fraction. X and z go on top. Y goes on bottom. Why did I do that? Because this has a positive sign in front. Again, we'll remove the parentheses. This is a negative. That means y goes on the bottom. And z has a positive in front. It goes on top. Solve. Okay. So let's see what's going on here. Okay. So we have log to the base 3. Okay, now, see this plus sign? Same base? That means we can condense this. So let's do that as we write it. We have log to the base 3 of x times x minus 2 equals 1. We're now going to do whirlybird. So we're going to end up with 3 to the 1 equals x squared minus 2x. If you missed that, here's your argument. So let me back up and do that in a step. 3 to the 1 is going to equal x times x minus 2, and that's what you get, x squared minus 2x. Okay, so now what we're going to do is we are going to take this and rewrite it as x squared minus 2x equals 3. We're going to take this and we're going to do minus 3 equals 0. Okay, so all I did was bring the 3 to the opposite side. This is factorable. That is going to be x minus 3 times x plus 1, all right, equals 0. Now I always double check my work. X squared minus 3x plus x is negative 2x minus 3. Good. Okay, so now we're going to set both of these equal to 0. X minus 3 equals 0 and x plus 1 equals 0. Recall, that's what we do when we factor. Here we're going to, final answer is going to be x equals 3, and this is going to be x equals negative 1. Now we go back to our original equation and we look to see if there's any extraneous solutions. X equals negative 1 is not a valid solution because you cannot take the log of a negative number. So therefore this gets crossed out and this is our answer. If we plug in 3 here, this is positive. 3 minus 2, that's positive. So x equals 3 is a legal and viable solution. Number 25. Okay, again, we're going to condense this. We're just going to simply say, notice the base is the same. Always double check to make sure that that is the case. So we are just going to do log base 4 x plus 1 times 5 is equal to 2. We're going to do whirlybird, and we are going to get this argument, 5x plus 1 equals 4 squared equals 16. 5x plus 5 equals 16, and you could solve for x. Okay, 26. What's going on here? Okay, same thing. We're going to take this, we're going to raise it 3 to the third, set it equal to the argument, and solve for x. So let's do that in one fell swoop. So we know that x squared minus 22 is going to equal 3 to the third, which is 27. Okay, we're going to bring this to this side, and we're going to have x squared minus 49. This is the difference between two perfect squares. So we know that's going to be x plus 7 and minus 7. So we know our final answers are going to be -7, +7. We do a quick look to see, are these valid solutions? We plug them in here. Whether it's -7 or +7, you are going to get a positive answer here. And the answer is positive, so we are okay. Okay, number 27. Oops. Okay, so what's going on here? We have a 4 out front. Let's bring that back up. That gives us log base 2 of x to the 4th equals 8. I failed to mention we have 2's, we have 4's, we have 8. 2 is going to be the star of this movie. So now we do whirlybird. We have 2 to the 8th is going to equal x to the 4th. We are going to say to ourselves, okay, this 2 to the 8th can be written as 2 to the 4 times 2 equals 2 squared raised to the 4th power equals x to the 4th power. Therefore, x must equal 2 squared. X equals 4. Again, 2 is going to be the star. Sometimes you have to manipulate this exponent to get what you want. But ultimately, you know that it's going to involve 2's. Solve. Okay, what are my thoughts here as I look at this? I'm going, since I have a common base, I'm just going to be multiplying these two within the same log. Log base A of x plus 4 times 3 is going to equal 0. I'm going to have a to the 0 equals this. A to the 0 equals 1, as does anything raised to the 0 power. I'm going to distribute that 3. We're going to get this. And then you will solve for x, and you will get x equals -11 over 3. Next one, number 29. Okay, same base. We have a minus sign. That means that goes in the denominator. That stays in the numerator. Gives us log x plus 2 in the numerator over x equals 2. There's an understood 10 here. That's in a parentheses. If we do whirlybird, you will get 10 to the 2nd power equals x plus 2 over x. 10 squared equals 100. Put that over 1. You now have two fractions facing each other, separated by an equal sign. That's a license to cross multiply. When you do that, you get 100x equals x plus 2. 99x equals 2. X equals 2 divided by 99. That's your final answer. Okay, evaluate these. Here, we're going to use a calculator. There's a log base 10 here. We're just going to do whirlybird. So the first one is going to be 10 to the 3.0125 equals the argument, which is x. and you just do this in a calculator. You use the XY function on your calculator, and you get x equals 1029.2. Next one. Okay, what's going on here? All right, this is number 31. Here, you can't get a common base. All right, there is no star of the show here because you got this crazy number 41.7. So when you're in a situation where you have exponents and you can't get a common base, how do you handle that? You take the log of both sides. Now, when you take the log of both sides, you have a choice between natural log or log. If you see e in this equation, you use natural log. Okay, I don't see any examples with e, the letter e. So in the absence of e, you can just use regular log. All right, so we're going to have log to the 3 raised to the 3x plus 1 equals 41.7. So I deliberately made that mistake on purpose. I forgot to take the log of that side. Don't make that mistake. Okay? Don't forget to take the log of the other side. 41.7. Okay, so ladies and gentlemen, this is calculator friendly. All right, you can plug in 41.7 and hit the log button. So that's very friendly. Now, what we're going to do here is we're going to bring this 3x plus 1 out here. And we're going to be left with 3x plus 1 times log of 3 equals log of 41.7. This is calculator friendly. We're going to divide both sides by log of 3. Okay, get rid of it here. And we're going to end up with 3x plus 1 equals some crazy number you're going to get with the calculator, and then you simply solve for x. Okay, 32. Okay, looks like we're going to end the video here. This is more of the same. This one here is taking 10, raising it to the negative power. You can plug that in a calculator and get your answer. Here, we would do this one. Okay. Let's see what we would do here. Okay, so the first thing we would do is take this and add it to the other side. So we would get 3.1 to the x power equals 6.7 plus 2 would be 6.9. Now we're going to take the log of both sides. We're going to use regular log because there's no e here. We're going to bring this x out front. See, I did it again. I forgot to take the log. Both sides. Now you're going to divide by log of 3.1. Log of 3.1. You're going to enter both of these in your calculator. You're going to get some crazy number, and that is going to be your final answer. Let's see any more. Okay, complete the following proof. I'm not going to do that on this video. Thank you. End of video.